Is quantum computing a scam? Some people think it is. Let's talk about it. Welcome to the Cloud Computing Insider. This channel explores the ins and outs of cloud computing without an agenda or following into the narrative set by big tech marketing. We look at what works, what does not, and the actual value of this technology in a balanced and information-forward way. If that interests you, please subscribe, like, and comment. I'm your host, David Linthicum, author, speaker, technology truth teller, and B-List Geek. Let's get started. So what we're going to look at here is really the value of quantum computing and how it kind of relates to the enterprise. Well, how does it relate to cloud computing? Well, most of quantum computing is going to be leveraged through cloud-based infrastructures by enterprises out there. And so it's a valid question to see if there's actual value in this technology, given the amount of time, focus, research, and development that's undergone right now around the use of quantum computing. So first, let's provide you with a quick definition. Quantum computing harnesses quantum mechanics. It is the weird behavior of particles at the atomic level to perform calculations that would be impossible for traditional computers. While classical computers use bits, such as zeros and ones, quantum computers use qubits that exist in multiple states simultaneously, theoretically enabling much more powerful computing capabilities. For more information on quantum computing, there's hundreds of videos you can watch here on YouTube that can provide you with more comprehensive learning experience. I'm going to deal with the concept of quantum computing itself. Remember that this is directly related to cloud computing, considering that many of these quantum computing systems will be consumed as cloud services, but many will exist on premises as well. So what are some of the recent developments? Just recently, we've seen some interesting moves in this space. Google launched their new Willow quantum processor, claiming improved error rates and better scaling for real-world applications. AWS is getting into the action too, partnering with NVIDIA to integrate quantum computing with classical high-performance computing systems. And companies like Classic and Mitsubishi are also reporting up to 97% compression in quantum circuits, which could make these systems more practical. But let's do a quick reality check. So here's where we need to pump the brakes. Despite these advances, we're still talking about technology that requires an incredible amount of precision, extremely controlled environments, and generates error rates that would make your typical IT manager lose sleep. The United Nations has designated 2025 as the International Year of Quantum Science and Technology, but that doesn't mean your enterprise needs to jump on the bandwagon. So what about technical limitations? Let's break down the why. Current quantum computers require extremely controlled environments. They're prone to errors and need complex error correction. The cost of implementation is astronomical. Most business problems don't need quantum computers to solve them. So what's the enterprise perspective on this, or what it should be? Here's what technology leaders need to understand. Well, quantum computing shows promise in specific areas like molecular modeling and complex optimization problems. Most enterprise workloads don't require this level of computational power. Your supply chain optimization or customer analytics works fine with existing technologies. So let's look at the corporate ego factor. Let's be honest, a lot of quantum computing push is about corporate positioning and ego. It's about being seen as an innovative and cutting edge as possible, even when the technology itself isn't ready for prime time. Companies are spending millions on quantum initiatives that could be better invested in improving existing systems, enhancing cybersecurity, developing practical AI applications, and training their workforce. So what are the real risks? The biggest downside isn't just wasted resources, it's the distraction factor. When enterprises focused on far future technologies like quantum computing, they often miss immediate opportunities for improvement. There's also the cybersecurity angle. Quantum computing could eventually break current encryption methods, forcing expensive security updates. So let's take a look at this in a balanced way. Now, I'm not saying that quantum computing isn't important. It absolutely is, especially in drug discovery, material science, complex financial modeling, climate simulation. But for most enterprises, it's simply not relevant to current business challenges. So, what's the practical application of this technology? Here's what you should do instead of looking at quantum computing. Focus on immediate practical technology improvements, monitor quantum developments from a distance, but don't jump in feet first. Invest in quantum safe security measures gradually, and consider quantum computing only if you have a specific use case that truly requires it. So, what's the conclusion here? The bottom line is don't get caught up in the quantum computing hype cycle. Focus on technologies that solve your current business problems. Save your quantum computing budget for when the technology matures and can deliver real value to your enterprise. Remember, sometimes the best technology strategy isn't about chasing the next big thing, it's about making smart choices with proven solutions. Well, that's my take on quantum computing's upsides and downsides. What's your experience? Drop your thoughts in the comments below. Don't forget to like and subscribe for more straight talk on enterprise cloud computing technology. And also, don't forget about my mini courses out on LinkedIn Learning, my generative AI architecture course out on Go Cloud Careers, also my InfoWorld Cloud blog, and finally, my book, An Insider's Guide to Cloud Computing. So until next time, you guys stay very safe